sketching the sine curve and the cosine curve, but we were adjusting their period, their amplitude, and so on, so we had different periods and amplitudes for these things. So we left off with number 5, I believe. So it says, sketch the graph of the function, include 2 full periods. So if you notice, this is one of those ones that has like cosine of 2 pi x. When there's a pi in there, your period is actually like nice whole numbers. It doesn't involve pi. Okay, so if I have cosine of 2 pi x, my period was originally 2 pi. How has this period for cosine been adjusted? Is it a horizontal stretch or compression? You guys are looking at me with blank stares. Yay, Monday. Woo! It's a horizontal compression because we multiplied an x by a number, right? When we multiply x by a number, it does the opposite. So we do a horizontal compression by 2 pi. So the formula is that we take our 2 pi divided by our b value. So b value in this case is 2 pi. So our period is 1. So what does that mean? It means that cosine completes a full cycle in 1 unit. Like it's going to go from 0 to 1. All right. Does anything else change? Our amplitude. What's our amplitude? It's still 1, like it is for the normal cosine function. Okay, so we're going to have -1 as our lowest, 1 as our highest, and since it's cosine, it's starting at its highest point. And it goes down, and then it goes back up, and it does all of that in 1 unit. Okay, so you can draw that straight away and do all of that. But if you don't want to draw it right away, remember how I talked about the 5 important points? I could do 1, 1/2, 1/4, and 3/4, and then I have 5 guiding points. I go through the axis to the lowest point, through the axis to the highest point. Just make sure that you don't draw it like people always are like, oh, it's like an absolute value. No, it's a curve, right? So it's going to go down, up, down. It's what we call a sinusoidal function. So your homework said include 2 full periods, so this does as well. Yeah, do you have a question? What the period means? Yeah, and that's what I got a lot of text messages about. So a period is 1 full cycle, meaning it starts at whatever point. So we're starting here, and it's going to start the next cycle at that same point. So that would be 2 full periods there. Does that make sense? So we start and end at the same point, and then we're going to start and end again. So it's going to go down and then back up again. So that would be graphing 2 full periods. And I don't care how you draw those 2 full periods. You can do it like that, or you could do some on the negative side and some on the positive side. So if you didn't want to do from 0 to 2, you could do from -1. I can't go over. From -1 to 1 as well. That would be 2 full periods as well. I don't care how you draw it. Okay, so it's up to you. So let's say we go to 2. So that would be 2 full periods. Make sense? All right, so if I have 3 times sine of x, what's the only thing that's different than sine of x? The 3. So this is going to be the amplitude. So we call this an amplitude. This is a vertical stretch by 3. Those are the words we used in Algebra 2. Now we're going to use amplitude. Is 3. Same thing. So we're going to go 1, 2, 3, up to a height of 3, down 1, 2, 3, down to a height of -3. And the equilibrium line has not changed. It's still the x-axis. I always call that like the middle line, the equilibrium line. How does that change? Like, what if I wanted an equilibrium line of 2? What would I need to do?
2 plus 2.
Yeah, you just have like a +2 on the end, right? That would move it up to 2. And then our height, what would our highest point be if I had a +2? Our highest one would be at, what was it? Someone said it. 5, and our lowest one would be at -1. Does that make sense? Okay. So since this is the sine curve starts at 0, 0. And it wants to complete 1 full period by 2 pi. Because our period hasn't been changed. I don't have a horizontal stretch or compression. It's still sine of x, not sine of 2x or 3x or anything like that. So do you guys remember how sine works? So let's have it and have it again. So we have our 5 main points. And sine starts on the equilibrium line. It goes up to the highest point, down to the middle again, down to the lowest, and then the middle. So it's going to look like that. So if we want 2 full periods, we could do it on the right side and go all the way out to 4 pi. Or we could do it over here on the left side, it doesn't matter, and go to negative 2 pi. It's up to you. So down, up, down. That would be 2 full periods. Make sense? You guys got this, you're pros. Anna Catherine does not think she's a pro. Some of you guys have just good expressions. I can tell if you're confused or not. All right, so find the amplitude, period, and phase shift. So it doesn't say to graph here, we're just finding them. So what do we think? So what do we notice about the parenthesis part? We have 6x plus pi. Do you guys remember what we need to do in that situation? So we have 2 horizontal transformations. So we have to factor. So we have to write it as 3 times sine of x, or sine of, and then parentheses. And we have to pull out that 6. So we're going to have 6, and then x plus what? Pi over 6. Do you guys see why? So if I multiply the 6 back in, see how it becomes 6x plus pi? We're basically taking that pi part and we're dividing out by the 6. That's what it means to pull something to the front. We're dividing by it. Make sense? So if you graph this, it would not start at 0, 0 for the sine curve. Like sine usually starts here and then goes up and then down. Where is this one going to start? Oh, grab that chair. It's going to go what direction, left or right? Left pi over 6, so it's going to start at negative pi over 6, right? That's what we call a phase shift. Okay, so our phase shift, some books will say like negative pi over 6, but I just typically tell students write like left or right. So I'm going to say left pi over 6. What about the amplitude? 3. And then the period, so it was originally 2 pi. How's this one been adjusted? 2 pi over 6, which makes it pi over 3. Okay, and that's all we need. So this one doesn't say to graph. If you wanted to, we could graph it. I'll show you what the graph looks like. So you don't need to graph it if it just says find the period, amplitude, and phase shift. But in this case, it would start at negative pi over 6, right? And its period would be pi over 3. Here's what gets tricky. You have to be good with fractions. I know some of you guys don't like them. So if I'm at negative pi over 3 and I add, not negative pi over 3, negative pi over 6, and I add the full period to it, pi over 3, what number's that at? Think about it with degrees. If I'm at negative 30 degrees and I add 60 degrees to it, I'm at, no, negative 30 plus 60 is not 90, guys. Negative 30 plus 60 is 30, right? We would be at pi over 6, okay? So it would be right here. That would be one full cycle, starting at negative pi over 6 and going to pi over 6. This would be a period of pi over 3. Okay, and it's the sine curve. It's going up to a height of 3 and negative 3. So here's what it looks like. It's going to go up, down, down, up. And it's really tiny. Well, really stretched out, but tiny. Right, that's what that would look like. Does it make sense? Okay, so let's try the next one. This one's not going to be fun. We won't graph this one, but let's come up with the amplitude, period, and phase shift. So amplitude, do we know it? 2. Phase shift we have to figure out. So we do our 2 and we do cosine of. We got to pull out the 3. What are we going to have left in parentheses? T minus 4/3. You got it. Can you guys read my 4/3? It's a little sloppy. I don't think I made it better. Okay, so my phase shift is what direction? Right by how much? 4/3. And my period. Yeah. Here's why we're not going to graph this one, because it's right 4/3. Isn't that nasty? So it's like starting at 4/3, and then its period is 2 pi over 3, which would be 4/3 plus 2 pi over 3. It would just be gross numbers, right? So we don't have to graph that. All right. Oh, that's the end. Is that the end? There's nothing underneath it? Oh, wow.